Hey guys, Vince back here with another little video about Git. Today we are going to be focusing on understanding the difference between a Git repository and a traditional centralized source control. So we're going to take a look at the webpage on Confluence called Git Basics. So you can come and take a look at this later when you have a moment. At the top we have some basic terminology, which I'm going to skip over, and you can go and learn about those terms if you need to. But what I want to go to is to talk about the difference between TFVC, Team Foundation Version Control, and Git. So first of all, centralized source control is a way that many of us are familiar with, and we struggle as we move from that way of doing things to a Git model, because some of the assumptions that we bring in to Git are wrong because of how things are how they work in Git. So let's go through it. We're just going to go through the bullet points here, and I will discuss anything that comes to mind. All right, so in the centralized source control model, each developer has only one version of each file on their dev machines. Historical data is maintained only on the server. Okay, so what does that mean? So that means that all of the developers' machines share and interact directly with the server. That's a key point. In order to interact with a source control, your computer must be able to connect to the server. And we'll come to it in a moment, but Git is not that way. It is, in fact, it's completely disconnected. In the centralized source control method, developers check in their own change sets, and they do not check in commits. So there's a definition here. A change set is potentially a series of changes that have been made, perhaps over the course of several days. You would make some changes, and at the end, you check the whole kit and caboodle in one shot. The whole thing goes in up to the server. In Git, we'll see that it's actually not that way. Git will keep track of each individual save, or commit, as they call it. Each individual commit that you make, it saves them all one by one, and then pieces together your check-in, if you will, to Git will include each individual commit. All right. The next time that other users get latest from the central repository, they receive all other users' changes that were checked in, or change sets that were checked in. So that's nothing is too different there. Branches are path-based and created and stored on the server. So again, centralized model, everything, the server is the master. And if you need to do anything, if you want to check any code changes in, your computer must connect to the server and check them in. If you can't connect to the server, you can't check them in. All right. To change branches, you must again connect to the server, since it's a central repository. So examples of this type of model are Team Foundation Server, which uses Team Foundation version control underneath the hood, or if you've been around for a few years like me, you remember Visual SourceSafe, and Subversion is another example. So there's many others as well, but those are the three that we've called out here. All right, so let's go to a distributed collaboration model. This means, for our purposes here, it means Git. So let's go to read this information first, and we'll go to this diagram on the right. Each developer, okay, first point is super key. Each developer has a local copy of the source code repository on their dev machine. Okay, absorb that for a second. It means that once we get that repository from the remote repository, once we bring that down, once we clone the repository, as we call it, then we have an entire copy of the entire history for that branch. Okay, so if we want to work with that copy, and make some changes, make some commits, as we call it in Git, then you can do that. You don't need to connect to the server to make a commit because it's disconnected. Developers can commit each set of changes on their dev machine and perform version control operations such as viewing history, comparing your current version with a previous version. All can be done without a network connection. Later, when you're ready, you can merge, publish, or dispose of any branches that you have locally that you've created that haven't been shared with the server, or you can share those branches and commits with others by pushing your local commit to the remote server. Similarly, as the distributed model or as the centralized model, the next time that other users pull changes from the remote repository, they will receive your commits. And let's leave this next section here for a moment, because this is where it also starts diverging pretty quickly from the way that TFS works, or the centralized. Let me open up this diagram and let's take a look at this a little bit more closely. So this diagram, let me try this again. No, it didn't work. All right. So this diagram shows us how the distributed model works and how, here we go. Maybe I could do this. There we go. We have a remote repository, just like we do in centralized, where this is where the master data is, the deciding copy. If there's any data anywhere about the repository, this is the one that matters the most. Okay, we want to start working on it locally. What we'll do is we will clone it, and then now magically we have a working copy of the entire branch that we just pulled down. So for example, if we decided to work with the develop branch and we cloned that repository, then we have an entire copy of the development branch. When we are working on it, there are 3 stages that we go through as we're working through things. So we have our working copy. After we are satisfied that we're making changes, with the changes that we've made, we will stage those changes, and then we can commit those changes to our local repository. So again, everything here is local. Everything on this developer A machine is happening locally. So I've worked on it, I've staged it, I've committed the changes, everything is local. When I decide I want to push it out to the remote repository, what I do is I go through a series of operations. First, I push the changes up to the remote repository, and then I will once again clone. This all happens behind the scenes. It will once again reclone the repository. So it's only after I've done that push that my code changes are ending up in the remote. So you can imagine that you can make a series of commits over the course of, let's say, 2 days. You make 5 or 10 or 15 different commits, all small changes, one by one. You check them all in to you commit them all to your local repository, and only when you're done and you're satisfied that everything is working properly, oh, I found a bug, okay, another commit, let's fix that. When you're satisfied, then you can push everything up to your remote repository, and it's now sitting in remote. Only once it's in remote can other people, other developers, developer B in this instance, can they actually see it. So that sounds pretty straightforward. Well, that should be pretty obvious, that last part there. All right, let's go back to our text. Branches are lightweight. Okay, what does this mean? If you think back to the centralized model, you might remember that creating a new branch was a kind of an ordeal. If you created a new branch off of the develop branch, it might take, depending on the size of your code base, it might take 20 minutes for the whole branch to get created. The reason it takes 20 minutes is because what's happening behind the scenes is that the source control server is actually physically copying all of the files from the source branch and pasting them, if you will, into the target branch, and then creating an entirely new version. Not the case in Git. in Git, what happens is, if we refer back to our example earlier, if we have a series of commits that we've made over the last 2 days, and I want to create a branch, that branch is just a pointer. It's literally like a C++ pointer. It points at a specific commit at a specific point in time. So the operation of creating a branch is very simple and very quick. It's just a pointer. We're not copying files. It's not doing anything like that. Okay. So that's a key point, because what it allows us to do is it's easy, simple, fast to switch contexts. So for example, if I am working in the develop branch and I'm working in a feature branch that is created off of the develop branch, perhaps I'm working on a new feature for a project. And then suddenly, I run into a point where I've realized I don't have enough requirements to continue on that particular feature, because I need some information from, let's say, the business analysts team. So I can't proceed. What do? Well, you commit all your changes to your local repository and you switch branches. That's it. There's no need to, you can just pause your work. You won't lose anything. And you create a new branch off of the development repository, off the develop repository, and let's say we continue work on feature number 2. You just switch over to that branch and you continue your work. When we have enough information to resume efforts on feature number 1, then you commit all of your changes that you were working on your feature branch 2. You just commit them and switch back to the first repository, or the first branch, I'm sorry. You can move back and forth. Now, sounds great, but let's compare it to how we would used to have to do things in a centralized repository. There was generally 2 strategies in the old way of doing things. One, somebody would create, or let's just use myself, I would actually create physically a new folder in Windows Explorer. I would create a new folder to put my new branch into, because what I would do is I would create a new folder, I'd save it, and then I would create a new branch out on the centralized repository, copy or get latest, as the words were back in the day, get latest of that new branch into this folder. I would now have 2 entire copies of the source code, one for the develop branch and one from this new folder branch. And so, for example, if the source code was 1 gigabyte in total size, I would now have 2 gigabytes of source code on my machine. Okay. And then I would close Visual Studio. I would reopen Visual Studio and then open the solution file that exists in my new folder. Okay, that is the centralized way, and that's the right way to do it, but we don't need to do that in Git. If I look at this quick order solution as an example, you'll see here in the folder there's this .git folder, .git. This is your repository. This is entirely all of the information that Git needs to know about your branches. So when you switch between feature branch 1 and feature branch 2, you use exactly the same source code, but behind the scenes, unbeknownst to us, Git is managing the differences between those 2 branches inside of this folder. Okay, we're not going to get into the technical details, but the point is, you do not need to reclone. Listen to me here. You do not need to reclone the source code or create a different folder to have different copies of source code, different copies of branches. Doesn't need to be done. You can do it all in a single copy of the code, because Git manages it behind the scenes for you. Okay? So that's an important one, because when I first moved over to using the distributed collaboration model, the Git model, I didn't understand that, and I was really confused. So at the end of the day, last bullet point here says you can quickly switch from one branch to another to pivot among different variations of your code base. So that's it for this one. For this video, you can follow along. The next video in the future is going to be a stepping through of creating branches and checking things in, or committing changes, I should say, and so on. So I hope you enjoyed this, and we'll talk soon.